Okay. So let's see. Homework. Modifier, no language support functions that take 0 or more parameters. How'd that go? You said not pretty good?
Once I figured it out, pretty good. Once you figure out the parser,
Oh, by the way, I did get your message and then I left it on. I went and
oh, my message about
yeah, the
yeah.
And I got your message too. Both of them are currently sitting in Slack showing that I haven't read them. So I will process those today. What I'm actually going to do though, since she was asking for assignment 5, I'm gonna hide assignment 4. Because she specifically told me it wasn't done yet.
Oh no, that was for grad class.
That's what I'm talking about.
Oh, you're gonna hide it?
Yeah, so you won't be able to submit that, but I'll open the next one. Hey, 2 people can play this game is what I'm saying.
Figure out, let you know you didn't have to do it right away.
Well, what's funny is it's supposed to happen automatically.
See, I'm wondering if there's only 6 units, so I wonder if you have it like timed so it.
I didn't grade it. Yeah, I mean, I made the content, but I sent it to people who put it to Blackboard, defied it.
It's like online people, they make it classes with the
All right, what was I talking about? Oh, there. 8.2. Do mathy stuffed toaster. Ooh, that just put me in a better mood. All right, so let's see. We're upgrading our functions, right? Okay, so we really have 2 pieces to this, right? We have the representation of a function itself. Those are our lambda dealy flippy things, or functions is that what we called it? Very great naming convention. So we have to upgrade that so that the parameter list can take more than one thing, because right now we make the assumption, at least I'm assuming we make the assumption, that we have exactly one symbol in there, when we may have more than one symbol in there that we then need to deal with. Then we also need to handle it on the what is it called? The call expression. Our call expression, which the presumption is the first parameter is a function and the rest of the parameters are going to be no expressions, no language thingamajigs. And let's see, so we need to go up to where's our documentation we've been creating? This guy? Okay, so here's our no language reference. And actually, why don't I'll copy this. And we'll just update that here. So now a function no longer takes in a single symbol here. Now it takes in a list of symbols. And a call takes in a no lang expression. And then we need to decide how are we going to handle the rest, because what could be here is 0 or more parameters, right? This is how we pass parameters into our functions. So in the language reference itself here, we're saying you could have 0 or more parameters, which then translates into we need to pass in 0 or more things for those parameters. All right. So how might we do that? Could I create a new production in my grammar? Maybe called list of expressions, where this guy takes in, this guy could be represented as a list of expressions. This isn't the way you had to do it, but it's the way you could have done it, right? So we can decide that, hey, we're going to now have something that's going to be a list of expressions. Now, might that be also handy for some other aspects of our language? Maybe we get into things like loops and stuff like that, where we want to do more than one thing. It's part of the body of the loop, having the ability to have a list of things that we intend to execute might be a handy thing. So let's add something to our language here, because we certainly could have done this. In fact, why don't we, let's do it the other way first. The way that basically just works for this. Just keeps this particular problem we're trying to solve in mind. And then we'll think about, okay, well, how handy could something more in our language be that we could also utilize here? All right. So because we know the nature of this guy, when we have our no lang expression here, which we presume is going to be one of these function guys, which we presume now is going to have something here that's going to have 0 or more things in it, we could always pass the rest of this guy back to initially our parser and then our the whatever we call it, the execute dealy flippy thing. We can pass it back to that as a list of expressions. Even though I just said we could add that to our grammar, we don't have to. I could just say, look, I'm going to take the what the cdr CDDR, which is going to be the list containing all of this crap, which might be the empty list or more. And then I will pass that through over and over again to get these guys filled out. Ultimately, that I'll have to probably modify my, well, what might be handy is to modify my variable environment, because right now we have the ability to add one thing to our variable environment. What did we even call that? Oh, we don't even have functions that operate in a variable environment. Oh, so we have every opportunity to do this. All right. So right now, when I add something to my variable environment, what do we just car on a list of these two things? And we're doing that inside of run. Oh, this guy right here. And this is the value. All right, yeah, so we'll fix that. Because it might be handy for us to have some functions that work with our variable environment that effectively do this, right? But when we look at this at a glance, this is starting to look a little bit sketch. If we I mean, the logic's going to be the same. We're just going to move it out of here and into a function that maybe says extend environment. And we have two different versions of that function. One, we can pass a single variable name and a single value, and it gives me back an updated environment. Or I can pass it a list of variable names and a list of corresponding values, and it passes me back an updated variable environment. Either way, we end up with an updated variable environment here. That's what this guy right here does. We get a variable environment with one more variable added to it. All that jazz right there. So if we offloaded that into a function, that could be handy for us. Okay, so now let's actually start with that. Let's make sure we give ourselves the ability, since now it's going to be handy for us to say, look, I want to add a bunch of stuff to my variable environment, not just a single value. So we'll go up to our variable environment stuff. And let's create a function called maybe extend DNB. And this guy will be a lambda that takes in. Now we could decide, if we want to just have a single, maybe we would just write a single one of these. Extend DNB takes in a list of variable names and a list of values. And it extends the current along with the current environment. And it extends that environment with those things. So lambda list of low vars, low vals, and a current environment. All right, so if I want to add A equals 5, B equals 7, I would pass it a list of A and B and a list of 5 and 7 to this guy. And he will spit out an updated environment with two new to lists on the front of that guy. All right, so the assumption we're making is that this list and this list are of equal lengths. All right, so we'll write a cond here. So we'll say null. We can say low vars or low vals. We'll boil down to the empty list. So if we've run out of variables to process, then we boil down to that. Actually, we probably don't want to boil down to the empty list. We probably want to boil down to our environment. That guy. We'll see why here in a few minutes. This is going to help us handle the what if I try to extend my environment, passing it an empty list and an empty list. For the situation where we say, look, yeah, you didn't ask me for a parameter. Yeah, you didn't give me a value. But I have nothingness. And I need an updated environment, even if it's not updated. So I can now ask this dude, I can say, here's nothing, here's the current environment. He hands me back the current environment. Go ahead.
If you did it the other way where you would go to the empty list, then have the empty list to that empty environment.
Correct. Well, it wouldn't,
would return.
it would effectively empty it out, because if you're expecting an updated environment back and you sent them an empty list, yeah, you end up with an empty environment. You lose all the old stuff too. Now, we wouldn't have had to write it this way, but we would have then had to do some additional checking outside by saying, hey, do you have something you want me to update the environment with? If yes, call this guy. If no, just use the current environment. Where now I can say, hey, I have this tool. I can throw nothingness at it, or I can throw 10 new parameters with 10 new values, and any way you cut it, it will give me a usable environment back. That's what this tool does. All right. So if it's looking null, return the env. Otherwise, I'm going to return, well, otherwise, we're going to call extend env onto the cdr of low vars, the cdr of low vals, and then an updated environment created with the cons. Actually, yeah, well, cons, the list version. And let me start kicking this down a line. The cons version of the, I want the car of this guy. And the car of low vals. So this will peel off the first value of each of these and create a to list out of it. I'm going to cons that to list onto let's see, whatever extend env. So let's see, I don't think I call extend env up here, but I have to on the rest. Yeah, I think I do. I'm going to extend the environment with this, the rest of the list, and this updated environment that will be created from
that you would.
Well, onto the current environment, because I'm already calling it on the rest. Yeah. Because I don't need to change the rest of this. I'm just updating that guy. So I'll cons that to list onto that and pass that now slightly updated environment to extend E and V. This guy. Ultimately, extend E and V is going to return multiple times where we'll empty out these guys. And then when we finally get down to the empty thing, we'll just boil down to whatever the final environment was. We could have done this in an if with an else. So that should give us an extend ENV. We'll test that here in a second. Because we want to be able to try to extend it on the empty list, and the original thing. And what's important there is this guy kind of functions two purposes. It'll function for if I call this extend ENV initially with nothingness for the list of vars and list of vals. It'll also be your natural end condition where we finally call extend ENV on the empty list here. And our final to list. Ultimately, it's just going to boil down to whatever was passed in, which was that environment. Our final state of the environment. So there's our environment here. Let's just go ahead and call extend ENV, passing it the list DEF and the list 1, 2, 3. And that should give us our here's our DEF 1, 2, 3 on the front of the environment we used to have. So that worked properly. And then let's just make sure it also works in the event that I pass it nothingness. It should. So there's our original environment unchanged. All right. So now I have a tool called extend ENV that will allow me to toss it a list of values and a list of parameters, list of values, and it will give in an environment. It'll give me an updated environment that I can now use. All right. So remember our cadence when we're updating our language is we update it in the parser first and then teach our run parse code to now execute that updated parse thing. All right, so the thing we're working with here is going to be our function section here, where right now we are creating our, we are creating our output here, which is going to be a list containing the word params. And then we are choosing to give it just the catter of our no code. That presumes there's exactly one input. But now I don't even know if I have any inputs. I know there's a parameter list, right? I know there's a parameter list. It might have it might have 0 things in it, it might have 50 things in it. So I can say, well, instead of just giving it the first element of possible nothingness, why don't I just give it the cooter of that no code? Okay, because the CADR gave me the first element of what was in the parentheses. Why don't I just say, give me all the stuff as a list? Give me the list of the parameters. Okay, which might be the empty list, or it might be the 50 list. All right, and then we have the body that shouldn't change, right? All that's should be the same. It's the only aspect of our function syntax that we have changed is the possibility for parameters to be represented differently. 0 or more instead of exactly 1. All right, but we did just change the expectation of our run parse code because now he's not expecting, well, he's not getting, so he shouldn't be expecting a single variable name. Now he's expecting a list of variable names. All right, for our call expressions are assuming 2 things, right? It's assuming that we have a function as our first thing, so that part doesn't change. We just updated the way functions are processed. And then the second thing, before we were assuming there would be exactly 1 value. But now there's not exactly 1 value. Now we have a whole bunch of values potentially. So how do we handle that? I ultimately want this guy to boil down to a list of parsed no code expressions, right? Now you could do this, you could maybe write a helper function or something like that to accomplish this, but couldn't we also use map to do this? Can I map this? So we can map no parser, which just takes in no code, a single parameter, across that list, right? Because it used to be CADDR. So now the CDDR will give me a list of no code expressions. And I want to map no parser across that list of expressions. Map this function across this list, which should give me, in the end, a list of parsed code. Good.
Can you also get rid of the line above that and just make it map and above it to the-
Well, let's see this line right here. So we're creating our call expression. So we're going to create a list with call expression. Then we're going to call no parser on the function. Isn't this still the function?
Yeah, but the function is also.
Oh, you could pass map across the entire thing, including the dude above it. Bottom line is what he's saying is look, the function is one of our productions of no code. Just as all of these parameter values are going to be one of those productions of no code. They shouldn't be it shouldn't be a function production, but it could be, I guess. So we could call map on all of this. And not even I mean, this isn't going to break. This will be fine the way it is, because I'm basically just saying, look, let's treat the function portion of it as the special citizen, and we'll deal with him. And then we'll map that same exact no parser function, the same thing we called here, across everything else. But map is going to give us, as a result, a list. So ultimately, it just depends on how do we want no parser to represent this guy. Do we want it to be a list containing the word call expression, followed by the single function expression, parsed, followed by a list of those value expressions? That will be the difference, as opposed to if you call map for all of it, you'll be left with a list that starts with call expression, followed by a list of a bunch of expressions whose car is the function. So I guess the answer to your question is yes, you could. You'll just have to treat it differently in your run parse code. You probably could make reasonable arguments either way. I guess my feeling would be if the job of the parser is to prepare the code to be executed, and we know that even though this guy is of the same animal type as all the things in here, we know we expect this to be a function whose parameters will be all those guys. I think it makes sense to separate them here at this level, even though the output of this is going to be the same as the output of each individual element of this list. So, I mean, I guess you guys can decide. I think this will be cleaner, even though we're not actually making an extra call, right? Because map is going to make that call. We're just choosing to manually make the first call and then let map handle the rest of them, producing us a list of values. Oh, I need coffee. That just broke something. All right. It's too late to be doing this stuff. 6 in the morning. This is way, way easier stuff. All right. So remember, the whole job of this guy is to handle the parser function. All right. So let's go ahead and test our parser here first. Let's make sure the parser is giving us the stuff that we wanted to give us. Let's see, what does my current code look like? So we'll pass it in X, Y, do we have a lit expression already? Yeah, we do. All right, so our new function we're going to try to work with here is a function that takes in 2 parameters. First parameter is going to be the result. Oh, actually, no, sorry. This takes in 2 parameters and boils down to those 2 guys added together. The first parameter will be the result of do mathy stuff, A mod B. Let's make that something bigger because mod gives you little tiny values. The second parameter will just be a 15. Go ahead. Maybe. Another parentheses, there's my first do mathy stuff. Oh yeah, that ends the function. And then here's the parameters passing to that function. All right, so we want to see what this guy looks like. And what is it? That? So let's just look at what the parsed version of that looks like, because we haven't updated our run parse code, so we fully expect that to break currently. All right, so hold on. Let me get rid of my extendee and B test. I get confused very easily, so the less stuff we have outputted here, the better. All right, so here's our call, here's our func, here's our params, here's our list of X and Y right here. Here is the, and this is the body of it. Is that right? List params. Func expression, it's opening 1. Yeah, that looks right for the func expression, right? Takes in an X and Y, and here's what it does with it. But the body, this is the part that looks, yeah, this looks like the wrong output. This here should be what's in here, right? The body. Isn't that? Well, yeah, but this guy is, nothing's happened to it. That's the original code. So we're creating a func expression. So that's parsed, whose params is this. The next thing here should be this stuff. Right. Well, it should be in the form of this guy. It should be the parsed version of it. So this guy's showing up 2 different times on that. So that has to be with my parser in my function when I'm appending the list of, so I'm creating my list that starts with params, followed by the coder of no code, which is all of this, the catter of no code. Oh, because before I was passing it the list containing a single parameter. I was only extracting the single parameter inside of run. So I still am giving it the list. The list just has more crap in it, or potentially less crap in it. All right, so now this guy has the params, then the body. Here's our math expression plus X and Y. That's the body of that. So that looks correct. Then we have a list containing our first math expression, which is multiply A and B, and then a list containing, well, I'm sorry, this is the math expression. And then the second element of that list is the parsed version of a lit expression 15. I think that looks correct. Our parser is giving us the right output now for that. Probably. Yeah. Right there, right there. All right, so we're happy with the parser. Parser seems to be doing the job. Maybe a good, this won't actually break anything, but let's just make sure it handles the no parameters. Certainly if you're passing it no parameters, but doing some mathy stuff on X and Y, that's going to require our language to support scopes. X and Y came from somewhere, right? I mean, we could force it into our environment, then it would work, but at least from a parse perspective, this should give us, oh, actually, if we take 0 parameters here and we pass it 0 parameters here, so now it expects 0 parameters and we're going to give it 0 parameters. So there's our function that takes no parameters, and here's the body that does some math on X and Y that came from somewhere. Presumably it was in your hard-coded initial environment, X and Y maybe here, and then it would be able to function. Okay. All right, so our parser seems to work. So now we need to go and update our run code. I'm going to separate these two. So I'm going to just call this guy parsed code, parsed no code to be that guy. And then we'll pass parse no code into run parsed code. I just separated them into 2 lines and stored my parsed version inside of a variable in case I want to print it out again. We're seeing here as we keep adding stuff to our language, it might be handy to be able to quickly just output the parsed version of our code before we execute it. In fact, you might even find it handy to always output the parsed version so that when you're debugging your run, you can look at what you're parsing and be able to walk through it. Probably make your life a little easier. Okay. So now we need to update run parsed code. And this guy is going to, we definitely need to update the call. We don't need to update anything up here. For func expression, we're still calling run parsed code on, this is the body, right? So we're executing the body in this updated environment where that updated environment presumably came from someplace else. All right, so I don't think we need to update func expression at all here, because we didn't actually modify the bone structure of func expression. We just internally modified the capabilities of it, but because we're still representing it as function or func expression, list of params, list of params, and then the body, we don't actually have to update anything here. So then the else, this is our call. We're going to run parse code. The CADR, so that's going to be this function. On, here's an updated, well, presumably this guy will be an updated environment, right? Okay. So let's actually. What that gives us right here, oh, right there, that guy right there gives us a slightly extended environment. So it's that stuff right there that we now need to update to get our extended environment using our extending and be better, right? All right, so we are running the body. Well, no, we're running our function here, which ultimately will be the body of that. In an extended env, extend env, and this guy takes in a list of vars and a list of values. So I'm currently, this guy right here is represented by this guy right here. So what I'm doing is I'm looking at all of this. This is my list of values, but currently, actually, this will be my list of parsed values. So what I'm looking at here is correct. So I have a list of values. And this guy here has my list of parameters. But I need this list of values to get executed in the current environment, right? Now, what they won't do right now, and this is kind of a caveat of our current language, is, where's my sample code? We don't have the ability to update our environment in other things yet. But let's just assume here that I had a variable D right here. And let's just make the assumption that whatever this function was, change the value of D. If this changed the value of D, we would expect that when this guy executes here, D would be that new value. As we currently have this written, our current capabilities say that this guy is executed in the identical environment as this guy will be executed within. The environment does not alter as we're hopping through that list of values. you are executing each element of that list of values within the same starting environment. Make sense? So as you hop through it, changes that might occur in a future version of our language that might allow us to modify values in the environment would not have an impact on the next guy. And we're actually going to see a overlap in this when we look at our, I'm going to show you some new syntax today for something called a let expression that has a similar limitation. That's why we have upgraded versions of let. All right, so we are extending our environment. The first thing we need to give it is our list of variable names. So right now I'm inside a call expression. So my list of variable names is going to be here's the car of the cooter, is going to give me that guy. The cooter of that guy will give me this guy. Well, will give me this entire guy except for this, and then the car of that. So the car of the cooter of the car, the kadar. So I'm looking at this. Take the cooter. Take the car of that cooter. And then take the car, let's see, take the cooter, take the, which gives me this. Take the cooter, gives me this, and take the car of that. So CADDR, right? CADDR, let's confirm that. Cooter, cooter, car. That'll give me my list of variable names. So for my list of variable names, I'm going to do the CADDR of parse no code. It would, so then I need the cooter of that. The cadadder. Cadadder. Could have a little stutter there at the end. Because what he just said is, wouldn't it give me this entire thing right here? When I actually only want the list XY. I don't want the params. That was extraneous parse stuff. Now an interesting, how many of you ever worked with jQuery in JavaScript? So an interesting reality to this is you actually see something along these lines. If you were, jQuery is a technology in JavaScript that allows you to rewrite portions of a web page without having to reload the web page. But the way it ultimately comes down to, it's not the first technology that lets you do that, but it altered the way in which you did that. Before that, we had a technology called Ajax, and let's just loosely use this in our example here. Ajax would have gone through this JavaScript, what's called the document object, would have gone through that object in a very similar way to what we're doing here. Effectively, the cars of the cooters, of the cadadders, and all this stuff. So really trying to get in there and piece out the exact little piece you wanted. Whereas jQuery effectively would have allowed us to say, get to the section called params. Pull out this piece. Under the hood, it was probably doing all the cars and cadadders and all that stuff, but it allows you to work with that document object in a simpler way. So there's just a connection to a real world example where we're doing something very similar to what we're writing here. We're effectively in the process of writing Ajax and wishing that we had jQuery in the moment. But this wasn't so bad. We were able to extract this piece. Let's see. So we're extending our environment. This guy right here is our list of variable names. Now we need to give it our list of values. So the list of values is going to be this guy down here. So if I'm inside my call expression, this is the cdr, this is the cdr, and then I need, that'll be the list of values. So the car of the cdr. So if this is my entire expression is in here, the cdr of that will be the list containing these two things. The cdr of that will be the list containing this list of expressions. And then the car of that will be the list of expressions. So I'll write it first. Car of the cdr, parse no code. That guy. But the problem is that what we actually want to pass to extend D and V is not this guy in and of itself. We want this guy with that has already been processed by run parsed code. Because this guy is filled up with parsed no code. Things that need to be executed before we actually get values out of them. When we ultimately extend our environment, we're extending this list of variable names with this list of values. Right now, what I'm giving it is list of variable names and a list of parsed expressions that haven't been executed yet. We haven't juiced the values out of these guys yet. So I need to get the values out of this piece right here. Now, what would be wonderful is if we could use map to do this. But alas, we can't. Why can't we use map to accomplish this? Yeah, it's just map can't do that. Map applies a single function to every element of a list, as if that element is the single parameter to that function. The function we want to apply takes two parameters. That makes sense? Well, you could write your own version of map. Why don't you want to do that? Just make it happen. Well, you could make it work. You just have to, I mean, so now we're connecting this to like network packets. I mean, if you have more than one thing that you want to send as if it's one thing, you wrap them in a package, right? You could put your parsed thing in there and your environment, and then you wrap it in a package list, call map on that, just make sure your function for map splits those guys out, and then calls your run parse code on that thing. Let's write that. Define run parsed map packet toaster. Run parsed map packet toaster. That's gonna be perfect. All right, so this guy's gonna take in a list of parse no code and an environment. Oh, actually, hold on. This guy needs to take in the packet. I wanted to take in a list whose car is the var expression and whose catter is the environment. And then what we would do is we would, oh, we don't even need to run this in its own. I don't think we need to actually write our own thing to do that. You're gonna hate this. This is gonna be so scary. All right, so we're gonna map something. What are we gonna map? We're gonna map a lambda that takes in our, what do we want to call it? What's our, takes in our packet. And what it's gonna do is it's going to call run parsed code on the car of the packet along with the catter of the packet. Oh, but I need to packetize. What? Oh, yeah. So good. If I want to turn this guy into a list of packets, then what I'll do is I'll call map lambda x list x along with our environment. So this is our packet. Our packet is a parsed expression, which comes from each element of this guy, along with my environment, which is a local variable of this guy here. So this guy produces a packet where each toList has a parsed expression and the environment. Map creates a list of all those. So I just packetized all of my parsed expressions. So that's what this guy right here will do. He'll create me a list of packets. That list of packets will be a list of toLists where the first element of each of those toLists will be our parsed code, parsed no code. And the second element will be the same environment every single time. Yeah.
I'm gonna ask what a packet is, but if you explain it, it has like,
Good. That's what this class is all about. If you've spent any time in this class since day one not confused, then you're in the wrong place.
what's a packet?
Well, I just said
But explain it better though.
a packet is a list whose a toList whose first element is unexecuted parsed code that I want to execute, and whose second element is the environment.
And would that unexecuted part code be a list bar expression?
It'll be like this dude right here. Well, yeah, no, it will be that guy right there. No, sorry. Well, here, I'll do the shorter one. It'll look like this. In our example here, we have two.
Okay, so it's the bar expression B and number expression.
Yeah, what I want to do is I want to packetize that list. I have a list of parsed expressions. I want to turn that guy into a list of toLists with each of those individual guys coupled with the environment as a single packet or a pill. And that pill is what's going to go into this map that takes in a packet and then calls run parse code on the car of that packet along with the environment associated with it. So we just created a map that allows you to have more than one parameter.
I really regret.
Hey, look, this is how things go.
Why didn't we do this in a separate spreadsheet? Why did we do this?
This looks way cooler this way. Well, we would have had the same code in another expression. And then what you have is you have this expression out there where you say, am I ever going to need to reuse this? Where this is really kind of a one-off thing. Like I need to massage this into a very specific format to accomplish what I want to get.
Because we're using that twice, but this is why it was the active.
Correct. Because ultimately, what are we trying to do here? We're calling extend environment. We're calling a function we wrote earlier today. An extend environment takes three things. It takes in the list of variables, variable names, a list of variable values, and that's what we're creating here. Our double map horror film here. That guy right there creates a list of values. And it creates that list of values by first packetizing the var expressions with the environment, creating a bunch of two lists that are var expression or a parse expression environment, parse expression, same environment, parse expression, same environment. So I'm creating a bunch of two lists, but a list is one parameter, which is what map uses. Map requires a single input. So then my second map is a function that takes in one input, a packet. And what am I going to do with that? I'm going to call run parse code on the first element of that packet, which is my parsed expression, and my second element of that packet, which is the environment. All right, so that gets me that. And then I'm extending that env. This is my list of variable names. This is my list of values. Call that the nightmare line. It's my list of values. And then here's the environment we're extending. And remember, what we're doing here is we're actually running. Let's see. So if I'm in this else, I'm going to run parse code. I think this is what I'm actually replacing this stuff up here with this. So I'm calling run parse code on that's the body. The problem is I added stuff after the code here, so we just need to see where we're starting off. So if I'm in this else, that means I'm looking at a call expression. What do I do with a call expression? I call run parse code on, this is the function, right? The catter of that parse no code. So if I'm looking at a call expression, the catter of this guy is the car of the cooter. Which is that. I'm running that func expression. That's what this piece right here is. The catter of parse no code gets you what I have highlighted there. And I'm running that in a new environment. It is the environment. So I've replaced this entire cons here with now my extend env. The updated environment that has now been created with my list of variable names, my list of values, and the environment that I'm extending. That should do it. Yeah. Correct, because this map right here, what that does is he produces a list. That's what the output of map is. This list will be our list of packets. A list of two lists with the first element of each list being the parse expression and the second element of each list being the same environment every single time. Where did that environment come from? Right here. So this guy right here, even though it's map, what does map do? He produces a list. It's a list of two lists, or what we're calling here packets. I'm now applying this function across each element of that list. This function takes in a packet, calls run parse code on the car of that packet and the counter of that packet. All right, what should the output of this be? Because this should be pretty cool if it just works. You don't think so? Oh, you see a bug? Don't tell me about it. All right. I've been excited for it for a while. All right, hold on. So you're saying I didn't write perfection?
One of them is
Spelling errors don't count though. If I made a spelling error, that doesn't count as a bug. That all right, all right. What am I expecting? So you wish it was just a spelling. All right, 7 times 5. What is 7 times 5? 35. 35 plus 15 is 50. So this should give us a 50 as our output. So let's make sure that our language here is written right. So call my function x and y. It's going to do that stuff. Now, do I expect this to take in a list of? No, because I've parsed that correctly. I think we're good. We're good. That code's accurately written. We're gonna run it.
Yeah.
Oh, so it's the too many things.
Yeah, you can't do that.
It's that certain function.
I feel like that still doesn't count.
There is more.
There is more.
That's the thing that you would stop at.
Yeah, but I actually followed the rules because it did go up to 4. You're just saying that some of the 4 combos don't
And
exist.
that's what I was saying the whole time. Everybody was like,
No, you said it only goes up to 3. You were very explicit.
But anyway.
Parse no code. Oh yeah, spelling error doesn't count. Oh. That was a pretty small bug. And then I have one extra guy there at the end. Oh no, map expects at least one argument given none. All right, so here's my map. Yeah, so here I'm mapping that function across that list. I support plus, don't I? Well, is my language written wrong? We're still safe here, mostly. Yeah, I have to have a symbol. Well, no, because I passed in something that I didn't give it false. It boiled down to false. because it didn't match any of those things. Because I passed in the plus sign, which is a function. All right. Okay, I got you. So do mathy stuff. Yeah, and I don't need it there. You're right, because I have this quoted. All right, so let's look at that error message again. I'm sure I did it on purpose. Hold on. Specs a number given a false. False comes from a resolve in our environment, this guy up here. So he boils down to false if I looked up a variable and didn't find it. So where's my addition? X and Y. Here's my X and Y. I'm passing in do mathy stuff, giving it these two parameters. Now see, the scary thing here is now this involves our map. No, the map's gonna work. Or it's gonna be your homework. Just fix it. Go. All right. So we're getting this false because when we're trying to do our mathy stuff here, and it's trying to resolve X and Y, does it tell us which one? Specs a number given false, but it's doing it on the plus sign. Plus expects a number, but given a false. Okay. So it's saying that X or Y, I'm guessing since it came up with the first one, it's the X. So it doesn't create this environment. So we want to see what environment this guy creates. So what we're going to do is just cheat for a second here. And we're going to have this guy just give us the extended environment. Let's see if we got the right environment out of the double map. Okay, so we do have it. We have a broken environment. Our original environment, as expected, is fine. And now it's been in a severe fire. Because what we've tacked onto the front of it is, now we got the 35. Hold on, so we got that guy, but we don't have it mapped to a. This guy. All right, so it's got to be. Are my packets wrong? What's he doing? Okay. All right, I just want to see if that first. I want to see if my packetizing is working. Okay, so it's saying that guy, the entire environment. Oh, wait, no, that's fine. Yeah. Because I'm creating packets with that environment. So then I'm going to create a list containing have an extra list. Because this is a packet, right? Yeah, so here's my expression. There's the 11 there. Oh, that's still my environment. So it's down here. It's the so here's a packet. I have a list of packets, right? First packet is this guy, which is my math expression, A times B, along with the environment. A times B along with the environment, that's right. And then the next one is a list with my lit expression along with the environment. Yeah, I think this looks correct. I know it looks scary, but it looks correct. All I'm doing is I'm showing what the first map is giving me here. Well, so it's the second map. Let's see if the second map gives me what I was expecting. The second map should take that packet and call run parse code on all the elements of that packet. All right, we'll come back and we'll fix it. I think we must have a little bug in our map. This code was pretty easy. I mean, when I had all the stuff that. Yeah, this is giving me my extended environment. So you want this to be changed to an A? The Kadar? Coder of the catter. When we do another catter like this. What does give it to us? That means nailed it first try. All right. So so we'll stop there. I'll post this code up, walk through the code, make sure you understand. This is, I mean, we were, because we have so much stuff going on. Actually, what's funny is we were extracting the easier part wrong. So we'll walk through this, make sure you understand what's going on. We're going to add to our language on Thursday. So no homework for Thursday besides walking through this. I'll put it up on Slack. What's chapel today? Is Matins?
Yeah.
Oy. Right. Well, they think they're doing it once a week.
Yeah. I think it's makeup for like last year.
Yeah, I get it. I mean, I respect it. I just don't like it. Man, a double map. That was fun. Well, I was so caught up in the maps that I didn't pull this out right. Oh, and then you were screaming at me about the, that doesn't exist. Get all whiny about it. Yeah. Okay. Okay. Just watch the video and do any homework.
Okay.
All right.